So within the transmission system, what are the parts? The shaft, bearings, worm screw, worm wheel, bushings. Okay, so these are all the parts which are involved within the transmission system. Now you need to have a housing which supports both static as well as rotating components. So in this application, for example, if you take the motor, the motor, the stationary part of the motor, okay, so you can see this laminated set with permanent magnets. So this is a stationary part. So this will have to be uh, mounted on the body. Then similarly, this shaft is mounted on bearings, and the bearing in turn will be mounted on this body. The bushing for these nylon worm wheels, once again, the station means that will be mounted on the body. So in the end, you need to have a structure on which all the stationary parts will be mounted, and the rotating parts will transfer the load to the stationary part either through a bushing or through a bearing. Okay, so um, you have, so fine, so these are some of the parts. And one important point to note is any machine that you take, you are going to have some loss within the system during the transmission. Now so if you take, what are the typical sources of power, mechanical power in machines? What are the typical sources of mechanical power in machines? Here you have seen it is a motor, more particularly a DC motor. What are the other sources of mechanical power?
Can be an engine, sir, petrol or diesel.
Okay, so internal combustion engines are another popular set of sources of mechanical power. So you have motors and internal combustion engines in most of the applications. There might be some other cases where you are using renewable energy, but fine. Now, between these two, which is more efficient, internal combustion engine or motor? Which of the two is more efficient, internal combustion engine or motor?
So motor.
Motor is much more efficient as compared to internal combustion engine. Most internal combustion engines can hardly give you an efficiency of about 25 to 30%. What happens to the remaining amount of energy which you are using to drive the system?
Heat loss.
It is
Dissipated.
as heat. Okay, so this is going to be a common feature in any machine that you are going to use. So for every unit of useful mechanical power output, there is going to be some amount of heat which is dissipated, and your ability to take away the heat from the system is going to be a very important part of any machine design. What would happen if you do not effectively take away the heat from the system?
The materials
It can
might be damaged.
So your operating temperature would increase, and that can lead to all sorts of problems. So particularly if you are using thermoplastics, then definitely you cannot allow your operating temperature to go above, let's say, 70-80 degrees. Okay, so fine. Now, so we have talked about the different parts in the blender. Now let us look at the different materials which are used. So in plastics, I have said worm wheels are made out of nylon. This fan could be something like polyethylene. It's not taking a lot of load. And this outer body, it could be something like ABS or high density polyethylene. So these are all the plastic parts. In addition, the outer covering of these wires are also plastic materials. Then, in terms of metals, what are all the different metals which are being used over here?
Copper.
Copper winding.
What are the different metals which are being used here?
Copper.
So you are using copper for what all application? For the commutator, for
Motor
the
winding.
winding, and possibly also within the transformer and
Wires.
the wire, which is bringing in the power. Wire could either be aluminum or copper. Then what else?
Steel is used.
Steel.
So you have steel. So steel is being used for the shaft, for the screws, and also within the bearings. Then we also have use of ceramic over here. What is the part which would be made out of ceramic?
The magnet.
Magnet.
Magnet. Okay, so the magnet would be made out of some ceramic material. Or okay, fine. So you have a bunch of different materials in use, and you also have carbon. Okay, so in the form of graphite for the brushes. Now, what do you think would be the most likely failure mechanism? So if at all this fails, what do you think would be the mode of failure?
The plastic worm wheels.
So most likely the first thing to fail over here would be the worm wheel. So over a period of time, you're going to have wear and tear. And if you apply some extremely high resisting torque, maybe this could even break, particularly after it weakens. So that is one possible failure. What other things?
The bearing.
Bearing failure is very little chance over here. Means the loads are minimal, and unless there is a very high heat which is sort of let's say drying out all the lubricant and then later on leading to failure, bearing failure is a possibility, but chance is less. What else?
Brush.
Sir, the copper
The
wiring
burning of
can burn
Copper
out.
winding.
burnout. Yeah.
Yeah, so if you overload it and somehow the winding can break if you overload the system.
The brushes.
The brushes can wear out over a period of time. So okay, so these are some possible ways in which you can have failure within the system. Okay. Okay, so now let me move on to the second case study.
Sir.
Yeah.
So why is nylon used here in the bombs?
So would anybody like to venture an answer? So question is, why not use metal gears? Why are we going with a plastic gear in an application which will encounter some amount of
So
torque?
maybe the weight will increase too much
Not too much. Not too
and the
much.
cost also.
Compared to the motor and all
The
that.
cost will be
How many of you know the cost of steel? If you take low carbon steel, what do you think is the cost of low carbon steel per kilo?
About 120, 140.
No. Anyone?
50 rupees.
Steel? So low carbon steel, when you take it in bulk, it costs about 30-35 rupees per kilo. Okay. It is way cheaper than any vegetable or fruit you can get in the market on a per kg basis. What do you think would be the cost of something like nylon per kg on per kg basis? Nylon would be
200
probably,
rupees.
yeah, so it would be somewhere about a few hundred rupees. So maybe about 200 rupees per kg. So whether you look at it on weight or volume basis, actually steel would turn out to be cheaper. On volume basis, it would turn out to be comparable. So material cost is not the issue over here.
Sir, cost of machining.
So manufacturing cost is definitely an issue. Okay, so making a metal gear would be way more expensive as compared to making a nylon gear. What manufacturing process would you use for nylon in an application like this?
Injection molding.
Continuous
Injection
injection.
molding.
So the per unit cost will be very less. For that is the reason that you have all these toy cars, no? They would be using similar kind of gears. So material means manufacturing cost is very low, and in the end the product cost would be very low due to use of nylon. Any other reasons? There are a few other reasons.
Heat
Temperature of operation
generation
temperature.
No,
Effectively it
not
would be used.
really. Not really.
So
Metal.
Sir,
whenever
the warm
uh,
wheels are
there is
rotating
moves
less
due to
number of
metal.
times than the warm gear, so maybe that's why they are made
No,
of plastic.
that's not an issue. That's not an issue.
So it can
So there
provide some
is
amount
a
of
spark.
lubrication.
Okay, so there are two more important reasons. So one is lubrication. So if you're going to use metal on metal systems, you need to lubricate it. Okay, otherwise there would be lot of resisting torque and also heat generation at the interface. And second thing is noise. So if you have an all metal system, the noise levels would be really high. You must have used the hand drill, right? So if you are using a hand drill, the amount of noise it makes is enormous. So over there you have a metal powertrain. So so you get a whole lot of advantages of going with nylon in an application like this. The sound level will be lower. The manufacturing and final unit cost will be much lower, and you can operate it in dry condition. You don't need to use any sort of a lubricant at the interface between these gears. But the disadvantage is that it has a finite life. It will not last for a very long time, but then the whole product cost is itself is not very high, so you would not mind if the life is just a few years for something like this. All right, let me move on to the next one. So the next product that I'll be talking about, I don't have much time, 10 more minutes, is a permanent magnet alternator. Okay, so um, what is the difference between a motor and an alternator? Alternator also has another name. What is the other? It's also called a generator. Okay, so see, all of you have traveled on trains, right? In trains you have air conditioned coaches. How do you think now these air conditioners, they have to run when the vehicle is running as well as when the vehicle is stationary, let's say when it is stopping at a station. Now do you think that they're all powered through, let's say, power cables taking power from the overhead lines? How do you think the air conditioners run on trains?
So there are generator vans, right, at the ends.
No, you don't have generator vans. So you means most of the trains have these engines. Okay, locomotive. We call them locomotives, and you have two types. So you have the diesel powered and you have electric locomotives. Now, in electric locomotives, you take the AC from the overhead lines, and then you, well, AC or DC depending on which line you're dealing with, and then you run the motors. But do you think but that locomotive is the only unit which directly uh, which takes the power from the overhead lines. So what you do in trains is that basically the wheels on the coaches, they have these pulleys mounted on them, and the pulleys, they rotate the shaft of a electric generator. Okay, and it is power from this electric generator or alternator which is used to operate these compressors for for air conditioning purposes, and also you use this power for peripheral lighting and other things. Now because the train doesn't run all the time, you first use this power to charge batteries, and then you use power from the batteries to basically run your system. Okay, now over here, so you see a frame. I hope you can see my mouse. So you see this frame. So this is the bogie frame. Okay. Now on the bogie frame, the permanent magnet alternator frame is suspended through this pin joint. So basically this can swing with respect to this axis. The permanent magnet alternator can swing. And then what you do is you have these belts which are connecting the pulleys on the permanent magnet alternator to the pulleys on the wheel shaft. And to keep the belts in tension, you make use of tension rods. Okay, you can see the tension rods which are behind over here. Now so just from the outside you can see a pin. Even though you cannot see, there is a bushing, nylon bushing, um, in which this pin is mounted, and then you have this outer frame where a whole lot of structures are welded together. You have a pulley, you have belt, the tension rod which is used for creating tension within the belts, and then sorry, here is a cross sectional view of the permanent magnet alternator. So the pulley is actually mounted on the shaft of the permanent magnet alternator, and using a key as well as through some other mechanism. Then you have a bearing over here. You may not be able to see the bearing. The rotating inner raceway of the bearing is attached to the shaft. The outer raceway is attached to the permanent magnet alternator body. And then you have some electrical stuff over here. Now if you take this whole system, okay, once again if you ask what are all the different parts which are used within the permanent magnet alternator, you can very quickly note that okay, you have pulleys, belts, spring, a belt tensioner system, you have the nylon bushing, steel pin, steel shaft, bearings. Okay, then sorry, very sorry. So fine. So these are all the different parts. So if you ask what are the materials which are used, so for the pulleys, what do you think would be the most likely pulley material? How do you think pulleys would be made? Most likely manufacturing process for the pulleys?
Casting.
Most casting. Okay, because pulleys have this complex shape, and their strength requirement is low, but shape is relatively complex. So pulleys, so in this case they are made out of cast iron. Okay, so fine. You have nylon for the bushings, you have cast iron for the pulleys, then you have what other materials are there? So the spring, what sort of a material would be used for making springs?
Something
Steel.
that can withstand lots of compression and expansion cycles.
uh, it's not the problem. So it is made out of some typically a high carbon steel, and it is used after hardening and tempering such that its yield strength and UTS are very high. Okay, so fine, you have that. And then for the shaft, what kind of a material do you think is used? shafts are normally, like in this case, the PMA shaft experiences good amount of stress, bending and torsional stress, and you use typically you use something like EN24 or 4000 series steel. Once again, after heat treatment and after a proper heat treatment to strengthen the material. For the outer body, what do you think is the material which will be used of the PMA?
Iron. Or steel.
Never say iron. Iron, you rarely use pure iron. It is some variety of steel. So in this case, it is a low carbon steel, some 1000 series or 2000 series steel. So fine. So you have a bunch of materials which are being used. What do you think will be the failure mechanisms in an application like this? What may fail during use?
So the belt of the pulley.
Okay, so
Tension of
belts may wear out or they may expand over a period of time, and you may, okay, that is one possible thing. What else?
the nylon bushing में भैया.
Very good observation. So nylon plastic parts are the first culprits normally. So yeah, so nylon bushing may wear out or it may deform over a period of time, undergo creep deformation. What else? What else? Okay, bearings are another thing that you have to pay attention to. Once again, bearings also after a certain amount of use, they may experience wear and tear, and you may have to replace them. Okay, so fine. So there are a bunch of these parts and some failure mechanisms that you have to look out for. So within this course, what we're going to do is we will start by looking at a bunch of materials which are typically used in engineering applications. We will then look at failure mechanisms. What are the different ways in which things can fail? Next, we will look at failure models. So, how do you how do you characterize failure, and how do you figure out for a given how a given material is going to perform in an application? So, we'll look at failure models. In failure models, you will be looking at brittle failure, ductile failure, and you will also be looking at fatigue, both low cycle and high cycle fatigue under multi-axial loading conditions. After you learn all these basics, then we will go into design of machine elements one by one. So we will be looking at bearings, screws, welds, belts. Okay, so we will be shaft. We'll be looking at different machine elements, and we will be seeing how do you go about either designing or specifying a machine element. In some cases, we have to design it from scratch. So if you are for a shaft, for example, you will be fully specifying the geometry, material of the shaft, and all that. But for some elements, for example, if you're talking about bearings, screws, for things like that, you will be specifying it. You won't design a bearing from scratch. There are manufacturers who make bearings, and you have to figure out which bearing to use. You have to specify the bearing which has to be used in the application. So for the second half of the course, we'll be going through machine elements one by one, and you will be figuring out either how to design them or how to specify them. The breadth of the course is massive. We will be talking about a lot of things, and what you have studied in a variety of courses will come into play over here. So you'll have to be patient. You'll have to follow the classes regularly, and do your assignments regularly. Okay, so this is it. Now what we'll do next. Okay, so just one second.